Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 330. Hit the like button, hit the subscribe button, join me on Discord, give me some love and hit some buttons because this was tiring. I did not solve this during the contest, and in fact, even afterwards, it took me a while. I think I was way close during the contest, or there are a couple of ways to say it. I think to be, and this is, the retro section, so definitely feel free to fast forward a little bit if you like. This is a very long video because it includes my live attempts during the contest. Most of it was just me like banging my head against the wall. I did miss one observation in the direction that I was going at. But yeah, I'm going to give you a little bit of postmortem. Like I said, you can fast forward. Just a little bit about the meta of the problem. One is that given that constraint n is equal to 4,000, there are a couple of n square log n solution that worked. Apparently, I should have, honestly, given that I didn't know any other answer, I should have tried it because, well, it was free if I was wrong and I would have gotten it right. But and the idea behind that is just around. There are a couple of ways you can do it, but basically it's just a lot of updates and keeping track of. I wish I have that solution still, but it's just basically yeah. For example, given a number, given a sequence like this, it is just literally a simulation thing. As long as you're able to do it in n log n or n square log n, rather. So and we'll go over the other solutions soon too. So don't worry. But yeah, but basically, given this, the idea is that you brute force two of the numbers. Let's just say in this case, I and I think it doesn't really matter. I mean, or not that it doesn't matter, but each of them has its own different solution, so that's fine. But basically, for example, if you did ik, you say I is equal to 1, the number num sub I is equal to 1, maybe that's a little bit better. Num sub k is equal to 3, no, num sub j is equal to 3, then that means that yeah. That means that you basically try to figure out the number of numbers that are bigger than the stuff to the right, right? And the problem with that is that you're going to double count stuff, but as you kind of iterate from left to right, meaning that because then here, let's say you have the number of numbers that are bigger, right? Then in this case, 5 would have 0 numbers that are bigger to the right, 4 has 1, 2 has 2, and so forth. And the way that I did it is with prefix sum, meaning that here, given that this is 1 and 3, we just count the numbers to the right that is between 1 and 3, or in this case 2 and 2, between 2 and 2, sum of counts that are bigger, right? And in this case, between 2 and 2, 2 has 2 numbers that are bigger, and so here for 1 and 3 you have 2 entries. That's basically the idea. And the problem is that you have to be very careful of your data structure because if you do 1 and 4, for example, then you're going to do between 2 and 3, but of course 2 and 3 is on the left, so you basically have to have something like a binary index tree or a segment tree, which is an advanced topic, but if you're able to kind of update as you kind of be like, okay, well, we already used 3, so we could delete it. We already used 2, so we could delete it. So then now, between 2 and 3, you can just do that summation, but in that case, it'll be that summation minus the 2 and 3, right? So that's basically the idea. And you can do that in n square log n, as I said, because you basically iterate all the I and all the j's, and then just kind of add and remove stuff from the segment, or either the segment tree or binary index tree on every iteration. That makes it n square log n, which for 4,000 is really big. So that's why I didn't really consider it, especially in Python. Maybe I could have YOLO'd it a little, or like I said, if I didn't have any other ideas, I probably should have been able to do it that way. And and just like do it, and then like I said, if it's wrong, then it's I don't have an answer anyway, and if it's right, then because Leetcode has silly test cases, then that would have been good. So that's one way to do it. I think so. The other thing that I was trying to find was an n square algorithm for most of the contest, and I kind of failed at that in that regard. Yeah, so I think as we talked about, let's say we have this thing not including the prefix sum, the number of numbers that are bigger to the right. So this is 4, this is 2, this is 2, this is 0, 0, right? So that's basically the idea that I had, but the two observations, two things. I would sometimes people call it tricks. I don't agree with that term, but just like two observations that, or two techniques, maybe that's a better word, that you can use, right? One is add another dimension. So I was focused on having one dimension, but you can add another dimension, which means that, okay, given what is the second? Yeah. So basically, what I wanted to say is, instead of saying, okay, for index I, what is the count of numbers that are bigger than I, or num sub I, we would do it for every number. That's basically the idea. Meaning, instead of a one-dimensional matrix, I would have two-dimensional matrix, right? Okay, so basically now, let's just say this is for 1, 2, 3, 4, 5. And what I want to say here is that for index 1, how many numbers to the right is 5 or bigger, right? So on index 1, this is going to be 1. This is 1, 1, 1, and then maybe 0, depending on whether you count the current number. And again, this is going to be 1 because at this 4, there's one number to the right that's bigger than 4, and this is all 1, right? So maybe I should put it that way. And then here, yeah, so how many numbers to the right are 3 or bigger? So that's not 3 or bigger. Like I said, it depends. I think I said, yeah. Actually, what am I doing here? These should be 2s. Well, it doesn't count itself, so this is 1, but then these should be 2, so sorry, friends. And then here, let me write it in the right way and say it in the right way, which is that at this index, how many numbers to the right are bigger than 3? So there's only the 4 and the 5, or 3 or bigger, not including numbers. So that's 3, this is 2, 2, 2, 1, 1, right? Something like this. Or not including the numbers, so yeah, sorry. Same thing for 2, right? Basically, you're just doing a lookup table of, I mean, I'm not going to throw it out just because I'm lazy. But you can have 2 tables, but I call it bigger, right? Of I, j is at index I, the count of numbers that are j or bigger to the right. That's basically the idea. Yeah, and then you also do one for smaller left, same idea, but now it's at index I, the count of numbers that are j or smaller to the left, right? So what can we do with these two things? What we can do with these two things is that now, and this is something that I struggled with because I thought that I during the entire contest, I thought about iterating I and j, and maybe at certain times I and k, but what I didn't think about was iterating through j and k. And let me just write this here, right? Because now, if we iterate k and j, then we can just say, okay, how many so now we can figure out how many num sub i's are there, right? And how many num sub i's there? The smaller left basically you want the index to be left of j, but you want the number to be num sub k or smaller, right? Maybe just -1 or something like this, but same idea, right? And then here to enumerate all the L's, to enumerate all the L's, it's just up, right? What is the index? Well, it's to the right of k, and then the number is going to be bigger than j, right? So it's j plus 1 maybe, give or take. So then now the number is just going to be this, maybe off by 1 on indexing, but number of counts that are here and the number of numbers that are here, and then you just multiply them to get the total count for a given k and j. And that's pretty much it. And it's going to be n squared because this is all of one lookup at that point, right? After you pre-calculate everything, also in n squared preferably. So now we go over the code. Sorry, there's a lot of talking, but yeah. And that's basically the idea here, is that given n, this is n, so we create all these numbers. Maybe oh, I forgot what my variable names are, but same idea. Left and smaller instead of smaller left, but you get the idea, right? So same as here. And here basically we just do the count, and then let me actually move this up. Basically we do the count for that number on to the left, and then we just kind of sum it up as like a prefix sum thing, so then you get the total count of all the numbers that are smaller. Same thing for the right side, and then like we said, we just do the j and the k, and then we do the left, and then we do the right, and that's pretty much it. And also of course making sure that num sub k is less than num sub j, and that we iterate in the right order, that j is less than k, or j is bigger than k. Wait, what? Might have gotten this mixed up. I wasn't able to submit it, but so okay, fine. But just go to J, right? I haven't been able to submit it because Leetcode is having some issues with the time limit exceeded. So, but I feel like it's going to be mostly right. Yeah, it's giving me time limit exceeded for some reason for an n is equal to 4,000 case. Maybe memory limit exceeded, but it was also giving me this issue for other people who have AC code. So I'm going to rewrite this tomorrow or whatever. But this is basically all the code, and that's basically all the logic. Yeah, let me know what you think. Let me know if you have questions. This is kind of a tough one. I didn't solve it during the contest. I think one thing I wasn't able to do was kind of get this logic about get this thing about this. But also, I think if I had one of those quote unquote hints, like if someone just cheated and gave me a hint, I would have gotten the other one. But I just kind of, because like I said, I was iterating on I and j, like on this loop, I was iterating on I and j, and I just couldn't figure out how to do the like in between stuff without an additional log n factor. There's also like sorted list solutions that you can do that just kind of, same idea as doing all these counting, but like I said, I didn't think n squared log n is going to work, but apparently n squared log n works in the contest. So I'm the dummy today, because I was trying to find the n squared, and I did learn a little bit. So maybe it's not a total loss. So yeah, let me know what you think. And obviously, this is just to be clear: n squared time, n squared space. So yeah, that's all I have for this contest, this video, and this contest, I suppose. So yeah, you could watch me solve a live in contest now. That was a hard one. All right, let's do Q2. Oh, wow. Actually, I guess I did the right thing by skipping ahead, maybe. All right, let's see. Because people haven't gotten it yet. This is a ridiculous contest. Okay. Okay. IKJL. Why did they put it this way? Well, obviously, N is too big to do. I'm gonna skip. Okay. Now to do the hard one. It would have been so much sweeter if I didn't spend the wrong answer on this one. A lot of people did though, it seems like. Alright. Focus. Okay, only 3 people got this one. I opened these points in a weird way. Okay. Okay. All integers. Oh, nums is a permutation. What does that mean? Can we pre-process anything? Increase quads. Even n square is a little bit slow though. I'm just writing stuff. Okay, so IJKL. This is such an awkward way. 1, 2, 3, 4. Oh, what am I doing anyway? How many people got the... Okay, so not that many people got Q2 or Q3, so I'm okay for now. But people have gotten Q2. This one though. Is n square fast enough? I don't even know. Is there a 2.3 thing? IJKL. So IJKL. IKJ. Basically like 2, 2, 2. How do I think about this? Permutation. Can I do it in another weird way? Also, I actually find it surprising that there's no mod on this one. Maybe. I don't know. Maybe it's just long. Okay. Still should use mod though, to be honest, but whatever. Maybe the answer is something weird that needs it. Okay, so permutation, that means something. That means that, okay, so going here for 1, can I do an n square? That means that I have to find a number that's 3, and then on the other side will be all the numbers bigger than 3, right? So basically, for 1, we look up. Okay, so if we have n square, we look up all the numbers that are bigger on the left. Oh, yeah, on the left and on the right, but on the right will be bigger than 3. And also, like, we have to do this in a weird way. People are really smart these days. But basic. Okay, let's say we have the third number. How do we... if we have the third number, I think there's something like that with the partitioning space. Let's say we have the third number. Then for every number to the left that's bigger, we just have to keep track of numbers smaller. And that's already 16 million times log n if we do it something like that. Maybe a little bit expensive. Please don't be segment tree. I don't know this one. But it is a permutation, so that means that there is like a. I mean, the permutation might not matter that much. Is there like a cycle thing of doing it? Right. What does this mean if I sorted this? What is this index? Okay, let's play around with it. So we sorted it. Whoops. All right. So then it's becomes 0, 2, 1, 3, 4. Is that easier? If we have the first two number, can we basically we can find all the numbers to so let's say we brute force on the first two, then we can do some math. No, I don't know. And yeah, because then the two numbers bigger than 2 on them, right? But that's still like n cube if we don't do it smartly, or n cube times log n or something. A lot of people are getting it. Well, maybe not. Reasonable amount of people are getting it. Can I divide? Well, even divide and conquer, well, not divide and conquer, but just divide in half has like 16 million entries. Why is it 4,000? That is just so weird. So uncomfortable. Almost clicked the wrong thing. Oh, I mean, that one doesn't do anything. But, does the other way to change anything? So basically, we want to index such that it goes up. Wait, which one is the index? This one is this is the index. So the index we want it to go the same order, really. Go up and then down and then up. Is it though? Can I do an n square? Because then it's just no, because then it has to be stuff that's afterwards. So for each one, yeah, but that's n cubed still. If we reconstruct backwards, maybe. Okay, let's say we do some suffix thing, right? With 4, okay, with 3, what does that mean? Okay, and then we add a 1, okay, what does that mean? I don't know what that means. Well, people get. Let's say we put first on I and K. Then what does that mean? So 1 and 3. Then if you do linear, you can't do linear scan. It's the same idea, Larry. Even n squared seems sketch, but well, maybe we can do a prefix something. So then here we go, not really prefix something. For this 2, we go, okay, there's 2 more numbers to the right. That is bigger, right? With 2 numbers in the right, that's backward. And then n squared by doing the math on all right, maybe that makes sense. I don't know. Let's give it a try. I don't have any idea. Okay, so so basically something like that. Let's just, and then for x and nums, you go backwards, because that's just the way that I was thinking about it. Bisect okay, get that real quick. Yeah, so 5 is 0, 4 is 1, 2 is 2, 3, okay. That's good, maybe. And then now we do, so 2, we want to prefix sum. In which direction? In the reverse direction. Now is it? So 2 should only have 2. Yeah. Oh, I see. Prefix sum is fine in either direction because you just subtract it. Silly Larry. Let's start at 1, we'll just ignore it. prefix I. Right. Okay. And then, oops. How did I not? Slightly more precise. Okay, so then now this would be just 2. Okay, and then I already have an N. Why didn't I use it? Okay, so then now, actually, what I want is just go to N for the array size, and then what am I doing? If J, then prefix of J minus 1 minus prefix of I, maybe. Well, maybe not quite that then. So this should be 2 minus 1. Oh, this is the indexes, not the values, that's why. No, it's still wrong, but props for trying. Nums of I, nums of J. Doing something, at least. 1, 3, we have 2. Okay, 1, 4. We want... Oh, but it includes this number, that's why that's wrong. I was thinking... Oh. Basically 1, 4. So this is wrong because it looks at this and then 2 has 2 numbers bigger. How do I keep track? I was playing around this idea, but I guess it wasn't right. Can I modify it? Is it going to the left? You want to see how many numbers that's bigger than. It has to be bigger than these 2, but not including this number, and also maybe not including numbers that we have seen before. I messed this up then, or at least with this particular one. Fun idea though. I don't know if I can keep track of it in a good way, that's why. So okay, so 1, 3, we look at numbers to the right. Oh, 1, 4 is weird because now we're looking at numbers to the left. So that's definitely weird. How do I keep track of it? I mean, because we only want to care about numbers to the right of 4. because wait, yeah. Maybe I could do that live, but then it's going to make it another n square log n, and that's like too slow, I think. Go 1 and then 5 and then we go okay. Add 5, 4. Nope. I mean, I guess there's a linear way to do it, but it's still really annoying. 1, 2, and then you go, okay, well, there's no numbers in between 1 and 2. 1, 3. Basically, we just do this, but going backwards. Paste it somewhere so I don't lose it. I'm gonna write something like this. No, but then you can't do the, at least not without a sec tree, and that's gonna be n log n squared log n anyway. Because you have to update it. A lot of people are getting this one. I was looking at only these two numbers and try to extrapolate. I guess we can build that, but not in a fast way for sure. How do we go from do 1, 5, okay, nothing to do it. 1, 4. 1, 2. In between 1, 3. Then you look at number of, you look at the 2 and then the number of numbers that are bigger than 2. But even that's not quite right either, because you can imagine like 1, 3, 4, 2, 5, and then it just tries, oh no, 2 will just add 1, so maybe that would work. But then if we add 2, then we have to figure out how to sum up all those numbers in between. Well, the 1 is static. But it's still like a prefix sec tree thing. Hmm. 1, 4, it thinks is 2 and 3. But it already saw 2 and 3. Can I subtract that out? At least, no, I mean, maybe, but like the 2, you can't subtract the 3 out. And then that's another sec tree query. IJKL, KJL, okay. Really misnaming thing, to be honest, but that's besides the point. People are getting it though. I'm not, not even close. That was the closest I got. But 1 4. I do something n squared. What does it mean by permutation? I mean, it is the same idea of finding if you have two numbers, then how do I subtract the 3 and the 2 out? Yeah, I mean, at least in a way that is in a sec tree. No way sec tree is fast enough, right? If it is sec tree, I'm going to be very sad. Okay, let's say we have 1 and 2. Let's say we have the first two numbers. Then we're now looking for the numbers to the left that is bigger than 2, and then numbers to the right that is bigger than that number. So numbers to the left, but this, I'm not really differentiating with whether we pass them. Well, no. Well, yeah, because you still have to sum it up in a weird way. Because if you have 2, then you sum up 3 and whatever. You know, you can process the 3 for numbers, but you don't know how many numbers. Man, I still have another 45 minutes to kind of suffer on this one. I don't know how my ranking keeps going up and down, but I guess that's just China though. I don't know how, there's still another way of looking at it. I mean, without loss of generality, they're all really the same. And you can't even do this for, okay. We have no idea. Because if you do it by index, it's the same problem. If we have one number, how expensive can we get? Let's say we have the third number. Then we want, yeah, wait, what? Yeah, let's say we have J. Then on the right side, maybe we can use something like this. Let's say we have 5, and then we go 4. All right, and then what we have to, and then 2 number. Now we just have to count. Now it's the same problem of finding a number that's bigger and then it's smaller than it before that. This gives us one thing, but still dynamic programming problem. This is a pretty hard problem. This Q3 was kind of hard too, but can I do DP? Is there a DP solution? People know it. I don't. I'm kind of blanking out today. 2, we have number of numbers that are smaller to the left. Numbers that are bigger to the right, that's easy. We already did that. And then 3 is bigger, but then before that, how many numbers are smaller than 3 to the left? But not just smaller than 3, but smaller than 2. Right? I mean, yeah, no, n squared log n is too slow. I don't get it. I mean, it could be n squared choose 2, but that only divides by 2. It's still going to be too slow if you have a log n. I keep on going back to it. I don't know. But is there a 2-pointer type thing I do? Okay. Because basically, let's say we have 1 and 3. We have a 2. No, but I mean, and then here. No, because it, I don't know how to do it. Maybe they just want to permutation. I mean, as long as they're unique, I don't know that it matters that it's permutation, because if they're unique, then you could reindex them anyway. I mean, the only thing I could think about is something around permutation cycle where you go left and right, but that's basically what I have here, except but that's like, you know, really wrong. So what was I doing? Still have half an hour, but I'm just not getting it. Let's see. I mean, so I'm looking at the triplets version. I'm looking for it, but it seems like I did it with segtree. Which I don't think is fast enough for this one. Definitely not in Python. People are definitely starting to get it, but it's still way to get it with IJKL. Is there something that makes this hard? Let's see, get inspiration from the n square version or the triple version, but the triplet version is just like n log n with either some kind of tree or something like this, which I know how to do, but can I combine two of these? Can I do n log square n? Is that a real thing? Kind of waste. Because you have to take to keep track of things you've seen. So 1, 3, you want to delete, when you get to 1, 4, you want to remove 3 and 2, because you already seen it. Well, can we do that math in a better way? We know that 3 has 2 bigger numbers, so that means that when we get to 4, we're going to double count this twice. Let's see, does that make sense? So we have to process this. We know that when we get to 4, we're gonna process this number twice. So then, does that make sense? I mean, it's still wrong, but but maybe I'm onto something. The 2, we have 2 numbers to the right, so that we know that we can count that twice. That's 4. And then 3, 4. I think that's what I have to figure out. Maybe the 3, 4 part. All right. Because here, this would be right. But then now the 3, 4, 3, 5, because 3, 5 recounts the 4, which as 1, so it double counts this. Okay, actually that works. But then now 2, 4, 2, 4. Why does it have 2? Because it looks for the 3. But 3 we already have done, so we need to figure out how to update this to be 0, because we already did 3. So, or alternatively, well, we know how many numbers are smaller to the right, and then you do math that way. So basically, that's true. So it's just the remainder. So it's going to be minus j, something like this. Maybe minus j minus 1. Okay, still wrong though, but good effort, Larry. Well, this is 0, but that's because it preemptively calculates this stuff. So it subtracts 6 because we think it overcounts by 6. Because, yeah, maybe. Then why is it still overcounting? 4, 5 is 0, it's 4, okay. 2, 4, it thinks it's 2 because it finds the 3 and then the and then it, I think this only happens once, maybe. This is very awkward though. Let's keep it here for now. So this 2 is right. This 2 is right, but then this has 2, 4 because it counts the 3. But the 3 is not on the right. And 2, 5 is even worse. But at least I think it already factors into 4, so it only does it did the 3 again. So this 3 is double counting twice here as well. In fact, it's double counting. Let's see. I have to put on I think. Maybe that's a little bit makes more sense. And then it's going to be just it's not every 2 because it only does, because 4, 5 doesn't do it, right? So it's every, I can't do it. I don't. I mean, we could do some summing, but I have to think about how to do it systematically. So 2 to the 4, but we already seen 3. That's the. I don't know if I know how to do it. So basically, yeah. This is even right, I think, now because of the 1, but how is, oh, should be J. It's counted here, but I don't know how to get it to not count in a good time. Because then now you have to do a permit. It's not just n choose 2. It is the sum of all the numbers that are smaller than it and then the number biggest number than it. So in this case, this is the number of count that this is counted is this. Is this prefix sum of? No, just no, but that is exactly this number, so that is very awkward. Just count it once. Two, 5, it double counted this again. Subtracted the 4 out because we processed it. Can we take out the 3 as well? going from 3 to, so 1 3, that's these 3 things, okay. And after that, that was just like random. I don't know how to do this one. It seems like basically we're saying that this 3 number will get, no, I think this is not even right. It get overcounted 3 times, one for every number smaller than it and bigger than it, but then it, but you want the number of times that it was before, or number of times that it is in between, right? And this isn't, I don't even know if this is the right path. Is it just seg tree? If it's seg tree, it'll be very sad. My ranking just keep dropping. It is what it is, though. I don't know how to do it. People got it very quickly. Maybe it's a stat. I don't know if it's a standard one, but I don't think so. I mean, I think the triplet one is probably pretty. Look at it. Like it's n log n one, right? And I don't. So we already have the n log n one. Does the non-uniqueness mean anything? No, it just makes it slightly easier to do what I'm kind of doing already. Still have 20 minutes, but yeah. But or maybe I count the opposite. Let's see. I mean, what's 5 choose 4? It's 5, and then there are 1 increasing sequence. Let me just draw it all out, write it all out. And then 3, 2, 4, 5. Missing a sequence. 4, 1, 3, 2, 5. 1, 2. 1, 3, 4, 5. Okay. Can I do like some kind of reverse Uno thing? So this is good and this is good. 1, 3, 4, 5 is no good. 1, 2, 4, 5 is no good. But then 3, 2, 4, 5 is also no good. That doesn't really help. It's not like, or at least it's not perfect inverse. Mm, can I count to the opposite? Maybe that's what makes this possible. Basically, it is just a monotonic sequence then, right? Well, and the opposite of it, maybe. 3, 2, 4, 5 is good. So then you just count the number of things that are if j is the smallest number, then it's no good. If I is the if the k is the smallest number, it's no good. If L is the smallest number, it's also no good. We could do math that way, maybe. I don't think so. One number at a time. So for each number, how many ways are there to get increasing things? That is also n squared log n. To do it quickly, maybe. Because the only one that I don't know is the increasing sequence one. Because then you can do the numbers where that's not all there is to it. I really don't know how to do this one. I might need a little bit of a hint, which obviously I'm not doing current contest, but I mean like afterwards. There goes sleeping early though. Yeah. An opportunity to learn. Yeah, it's also not good enough. So there's 4 numbers. There's really only 8 cases, right? Well, not really, but because then you could go straight up, straight down, do. We want that. But there's actually 4 factorial cases, maybe? Yeah, which is, what, 24? I'm not going to enumerate 24 cases. Well, I don't even know if that's possible, but or like, you know, without doing the same thing that I would have to solve for in this first place. Because one of them is it's a symmetric one, right? So 5 choose 4 and choose 4. Wow, I mean, I usually have some idea of why did he. If this is 1,000, do I know the answer? I guess n squared log n would have been fast enough for 1,000. Roughly, maybe. 4,000 seems tough, though. If it's sec 3, I would be very sad. Hmm. Oh, Yeah, I don't know. I'm beaten at this point. Hmm. Yeah, I don't know. Still trying to grind it out, but I don't feel like I could grind it out if I'm playing around with some ideas. But today I just don't have the ideas. Do TP on 4,000. Let's say I'm doing it backwards 1 to 5, and then for each number, just seeing a number that we've seen that is backwards. Maybe I should have done it that way, n squared log n. I think it's too slow though still. Permutation. Can't figure it out. What did I have? Because basically for every I and J, we look to the right to see, that's still, even as I say that, it's the same thing that I've been doing. I keep trying to do the same thing, but saying different words. And that's not cutting it. Oh, sorry, friends. I mean, there's only 9 minutes to contest. I'm getting this one. Seems like a lot of people are getting it though. So maybe just one of those days. I don't even know if this includes China. I don't even. That wasn't that fast, but that wasn't that slow on the first two. But also bad posture. Okay. Is there a DP based off n square? Not like faster than n square. I mean, I guess maybe some like. Is there DP? Let's say 1 and 1 to 4, and then we want to get a number that's bigger on the left, and then a number that's bigger than that on the right. Oh my god. For 1 and 4, you try to get a number that's between 1 and 4 to the left. And then, no, that's not even right. The J is bigger, right? So you want, if this is K, then we want a number bigger on the left and a bigger, even bigger than that to the right. But making sure that the partition and sum it up. I don't know this one. Just one of those days, I guess. And also Q1 sadness, but that's besides the point. Which one was Q3 again? Oh, mom was in bag. That one was going hard too, to be honest, but this one. Trying to keep on staring at it, but and sometimes that works. But today, Leetcode just picked a very competitive programming one for some reason. One day they'll realize that people are doing Leetcode because it's different, not because it's the same as all the other contests. But instead of embracing it, they kind of, try to be other things for some reason. That's it. I don't know. I'm just ranting because I have nothing else to say. There's only 3 minutes, and I'm not gonna lie. Usually I would try to grind it out if I feel like I have new insights. I feel like I probably already have the answer and just dismissed it for some reason. Like if n square log n is fast enough, maybe. I think if I was in a grinder mindset, which maybe today I wasn't, I would have maybe used a C++ sig tree type thing just to at least get a fail, I think that's one part that I'm kind of maybe a little bit sad about. Is that, yeah. That is so expensive, and like n square log n even over 2 is like 200 million, 100 million, something like this. And tree is not a cheap overhead thing either. I don't know. So I need the answer for this one. So I guess it's sad waiting, but it is what it is. I'm hoping to kind of see how to learn from other people's code. So stay tuned, whatever, and kind of, well, I mean, I don't know, if you're watching here, then you're probably staying tuned, but to see how I kind of approach learning something new, right? Maybe it's helpful, maybe it's not. I don't know. We have 2 minutes. I don't really have much more to. I don't have much more to do on this one. Hmm. If you're watching at this point, just going to ask you to, hit the subscribe button and hit the like button and all those other buttons. Why not? I don't know. I have nothing else to say. I'm just kind of. And this is over. The disaster is over. Okay, what is the. Is there like a specific album? The way our names are weird. Suffix and prefix. Oh, jeez. So this is like what we kind of did, but why am I so wrong on this one? I thought I kind of did it something like this. So okay. think this part is the part that I don't know that I understand. Like I think I mostly did the other stuff, and I could have, even though I did it in a slightly sloppier way. They did it with DP, and we, but I don't know. Yeah, I mean this is basically what, I mean, yeah. So basically, this is just doing the numbers of numbers that are smaller than I. Yeah, so I would be the number of numbers that are smaller than it, right? And this is very similar to my attempt of thinking about it, but clearly I miss a lot of stuff. And then here, basically this is the brute force that we were kind of doing. And basically, for I, oh wait, no, this isn't. This is one of these is index, and this is the. I see. So basically, this is the index of numbers that are doing that, and then it's just a lot of maths after that. See if I could get it without looking at it, maybe, or looking at it again. Okay, so basically, and this is this is how I try to learn, is that I looked at it and then maybe I understand it, maybe I don't, and I'm going to practice my thing. But yeah, but basically a sub I of j is at index I, the number of the number of numbers that are j or less, something like this. And I guess it becomes like a prefix array in that sense. So you do something like this. Yeah, oops. And then I mean, I have to prove that formula, so I don't remember the formula. I kind of, because it just looks ridiculous. But or like not gonna memorize it. But yeah, and then for I is n, and then basically. Maybe just whatever, just go in and one. Something like that, right? Okay, and then now what are we doing? So basically now we're looking for, I mean this is kind of weighted, but now we're looking for, okay, is this K or is this J? Let's say we have this. Right, so we have to look for numbers that are to, I see. I think that's the part that I couldn't figure out, is that I didn't have the extra index. So basically I was doing the same thing, but a variation of the same thing, but without the extra dimension of the indexes. And having the indexes kind of was the trick I needed. Okay, and then basically, yeah, obviously a video coming soon. What am I doing? Okay, so first of all, if num sub I is less than num sub j, right? Then, so this is j, so maybe we want k instead. Which one is j? So j, okay, so if we have I and we have j, then we want a number to the, do we want k instead? Yeah, because if we have k, wait, what? So we have an I with a loss of generality. Do we want the j? Because then we look to the right for the things, but if we have k, then we can look to the then if we have k, if this is a k instead, then we can look to the left for something bigger. But then the bigger has to be smaller, right? So how do I do that? Maybe that's the part that I still don't know. Maybe seems like they all have the same one anyway. I think that person did it a different way. Fenwick works. I thought that would be. I thought this would be too slow. How is that fast enough? It's 4,000 square. Okay, whatever. It is what it is. Good job on. I mean, I guess I should have tried it. I kind of knew it. Well, Fenwick is cheaper than Sectree. I guess I can't remember that. But okay. So they do J and K. Are those numbers or are they? No, unsure. What's it? I really should have done it this way though. But yeah, I thought this kind of solution wasn't going to be fast enough. I was query well. I mean, I mentioned it during the thing too. Like I should have switched to Java or something and do Fenwick. But I feel a little bit dumb. I mean, yeah, because then you just get the thing in between. Okay, maybe. Oops, one that I was cheating off. 591. That's that. So basically, this is what I have. What does this mean? I don't even know any more friends. Oh man, everyone. I mean, so in that part, I didn't learn. So I mean, I don't really feel bad about the n square log n1 because I don't. Oh man, really? This makes me sad though. Maybe because I was thinking about doing this, right? Like we had this pretty much. I should. This is just one of those days where I just didn't. Where I just didn't think about it to do it. Oh well, because that's basically my thingy. A lot of people did it with n square log n. I don't know what this stuff means anymore. I mean, I get the idea, but I'm just blanking out on the calculation. And even though a lot of these code looks the same, other than I mean the binary index tree and the framework one, I probably should have known, or I should have gave it a try at least. I didn't. Maybe the test cases on that trick, but I feel like I should have known how to do this one. So let me study this a little bit more. Okay, so given I and j, what is this saying? That let's just say that this is the left of it, right? Okay, so for each index I, what is going on in this code? Okay, maybe I'm just too tired. Okay, so one, what does this do? So for I is in the last number, okay. Oh, and then I missed this part. So the last number say 5, then it goes from 1 to 6, and then it just shifts all the numbers. I don't know how to read this one. Should have kept the other one up. But I saw one though. These are very similar to the other one, but I think the understanding I'm just a little bit lacking today. I like the way that I wrote it. I mean, yeah. Yeah, maybe I should have done it with segment tree. I knew how to do that, but I really didn't think n square log n would be good enough, to be honest. I was way wrong. So this is the one that I cheated off. Okay, I mean, I did it in 2 different loops, but yeah, I mean, I proved that because I understand this part. How did I get this part? I don't even know if I is j. So okay, so the part that I couldn't figure out is this part. So okay, let me just read it here. Don't want to. But basically, this is for index sub I, all the numbers that are smaller than j. I mean, this is just n minus 1 bit. So basically, this is the left, I suppose, of index. Oh, I see. I am being dumb. People aren't doing j or I or j. They're doing k and j. And then it just becomes the number of numbers that are here and here. Wow, I was way wrong. I think that's where I got stuck, was this loss of generality thing with I. But okay, so let's just say j and k, right? Okay, now I can. I mean, I stepped this on screen, but now I've. Wow. Okay, so I did miss something. Okay, so let's have j and k. Then we want okay, so let's say I have to paste this because I think I keep confusing it. This is a very specific thing. Okay, so let's say we have j and k. Then if if k, then now we want to the left of j that is smaller than k. So left of j, maybe minus 1, that is smaller than k, right? K or smaller, also maybe minus 1. And then on the right side, we want something that is I guess that's why people have left right, so that they could kind of handle this slightly smarter. But let's see. We want an L that is oh, because K is okay. So we want something that's to the right of K, but then we have to do like this reverse math thing. That's what the other thing was saying. Something that's to the right of K that is bigger than num sub J. Something like this, and then you have it's something like that, but you have to kind of get the reverse thing, which is where the math comes from. And that's kind of a little bit of a tricky one. I guess that's why people did the left-right thing. Oh, is this right? No, because this isn't right, is it? No, this is right. Yeah, let's just convert it then. Just to left smaller. And then maybe right bigger. Same thing. And then we just write it as for I in range of n minus 1, minus 1, minus 1, going from right to left for j in range of minus 1, I minus 1, something like that. Then right bigger of I num sub j increment by 1, right? And then same thing as we have there with the prefix sum. Okay, and then this is adding to right bigger nums j plus, oh well, in this case you don't need it like this. You just go from n to 1 or to whatever, I guess it doesn't really matter. And then it's just j plus 1, right? And then here, then it's just right bigger. We want a number that's in times num sub j plus 1, maybe. All right. Which one? Let's try this first. Okay, so this is definitely wrong, but you know. Okay. Let's do JK. Man, even knowing the answer, it takes me a while. Okay, so let's say this is 1 and 2. There's a lot of numbers. Oh, let's do num sub j and num sub k. for visualization. All right, so basically we have 3 and the 2. We want this should have been 2. 2 is actually right. So yeah, okay. And then now 3 1. Let me remove this one. I don't know if I'm confusing things. 3 1. Okay, so 4 and then 3. Am I doing this weird? 3 2 is right, JK. And then 4, where does 3 come from? Oh, jeez. Okay, that's silly, but that's easily fixable. Okay. Yay, this only took 2 hours. Can we just solve? Oh, yay. N square is too slow on Leetcode. What is slow about this? It's literally N square. Can I optimize this a bit more? I think Leetcode is just having server issues right now, maybe. Because that's just ridiculous. I don't think I can optimize that much more. At least in just pasting on Discord. Yeah, I don't know what. Ooh, memory limited exceeded. That's also ridiculous because we only have 4,000 square. I mean, I guess I might as well cheat a little bit more. Which one was I cheating off? Like, I mean, people definitely do it, you know. So. And this is clearly, and I don't get it. All right, let me copy this real quick. I'm just curious what. I mean, Leetcode is just having issues probably, but be funny if it suddenly works. I think Leetcode is just having server issues. Yeah, I mean, yeah, this isn't even my code, but I will probably. I mean, I'm not gonna lie. I'm just gonna resubmit this later. This seems pretty right, so should be okay. I'm not worried about it. Yeah, that's all I have for this content. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's explanation. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.